Okay, I think we'll get started tonight. Thank you and welcome to the University of Sydney and to tonight's Sydney Ideas discussion on the biodiversity crisis, environmental, social and economic impacts. My name is Christopher Wright and I'm a Professor of Organisational Studies and leader of the Balanced Enterprise Research Network here at the University of Sydney Business School. Before we begin the proceedings, I'd like to acknowledge and pay respect to the traditional owners of the land on which we meet, the Gadigal people of the Eora Nation. It's upon their ancestral lands that the University of Sydney is built. As we share our own knowledge, teaching, learning and research practices within this university, may we also pay respect to the knowledge embedded forever within the Aboriginal custodianship of country. So tonight we're here to talk about the biodiversity crisis, a subject of critical importance to the future of life on this planet. The Balanced Enterprise Research Network, which I lead, is one of several research networks at the University of Sydney Business School, and we aim to explore how organisations can aspire to a more sustainable existence, balancing their economic needs with critical social and environmental priorities. Byrne is also one of the 7 nodes of the Sydney Environment Institute, a cross-faculty research group which explores the fundamental relationship between human communities and unprecedented environmental change. So there's a couple of thank yous I should just emphasise at the outset. A big thank you to Sydney Environment Institute, which have provided funding for tonight's event, and especially Michelle Snan for helping with the organisation of tonight. A big thank you to Sydney Ideas and Meredith Hall, also for helping to organise this evening's event. So, the topic of tonight's discussion on the biodiversity crisis is obviously directly relevant to the concerns of Byrne and SEI, and it's a fantastic opportunity to be able to host this discussion. As you may have seen in the advertising around tonight's event, we live in troubling times, particularly in the way in which our species is now having a crushing impact on nature's bounty. Humanity has over many centuries developed ever more ingenious and efficient technologies to harness and exploit the natural world. However, in recent decades, our impact has become far more profound. Indeed, species extinction rates are now 100 to 1,000 times greater than their background level. Biodiversity decline has now become systemic, driven by our increasingly globalised economy, expanding consumerism, and accelerating climate change. According to many experts, we are now living within Earth's 6th great extinction event. So tonight we're very lucky to have 2 eminent experts on the topic of biodiversity decline, its causes and consequences, who you will be hearing from shortly and who you will also be able to ask questions of after their presentation. So I'd like to introduce our first speaker, Professor Lesley Hughes. Lesley is an ecologist in the Department of Biological Sciences at Macquarie University. She studies the impact of climate change on animal species and ecosystems. In addition to teaching and researching at Macquarie University, Lesley is an active participant in a number of conservation and climate change associated organisations, including the Intergovernmental Panel on Climate Change, the ICCC, the World Wildlife Fund Australia, the Climate Council of Australia, and the Wentworth Group of Concerned Scientists. At Macquarie University, Lesley is the co-director of the Climate Futures Research Centre, the director of the Biodiversity Node of the New South Wales Climate Adaptation Hub, and the acting deputy dean of the Faculty of Science. Lesley's talk tonight is entitled, "Can Biodiversity Survive the Human Race?" So without further ado, please join me in welcoming Professor Lesley Hughes.
Thank you for all coming, and thank you, Chris, for inviting me this afternoon. Okay, so that is my title. I've been asked to just talk for 15 minutes, so I'm going to race through this fairly quickly, but that's to leave plenty of time for questions later. When we talk about biodiversity decline, we talk a lot about extinctions. Chris mentioned it just then. But what's the big deal about extinctions? In fact, almost all species that have ever evolved on this planet, about 99%, have already gone extinct. Species last around about 1 to 10 million years, depending on what they are and what time they've lived in. And as Chris said, we have already been through, we think, 5 major extinction events in the Earth's history. And during those events, somewhere between 70 and 95% of species on Earth at that time went extinct, usually over a period of at least hundreds or thousands, if not millions of years. Even 1 million years is quite a short period of time in the Earth's history. So, there have been a number of culprits of this. Meteors hitting the Earth's surface and sending up big dust clouds, volcanic eruptions, ice ages, and that funny little lumpy icy bit over there is methane hydrates, which is frozen methane captured in a crystalline lattice in the bottom of the oceans, and when they get released, the Earth's really in trouble. I might be able to talk a little bit more about that later. So they're the past culprits, knocking off great swathes of species in the past. But these days, our biodiversity is built up again to the extent where we have somewhere between about probably 3 and 30 million species on the planet. We don't really know within an order of magnitude how many there are. There's probably about 5 or 6 million. And as you can see there, the numbers in some of these groups are pretty big, such as 4 to 6 million species of insects, 1.5 million species of fungi, etc., etc. Of course, there's only one species of us, and that's really the problem. So as Chris said, we now appear to be entering extinction event number 6, and this has given the name Anthropocene to the period in geological history that we're now in. It was coined about a decade ago to describe the period where human impacts overwhelm all others. And this is why. This is what's happened to human population growth over time, going back about 500,000 years. About 10,000 years ago, humans and livestock accounted for about 0.01% of all vertebrate biomass on the planet. In the 1970s, this had grown to 25%. And by the year 2000, 97% of all vertebrate biomass on the planet was either us or our sheep and cattle and other livestock. We are definitely punching above our weight. We exploit up to about 50% of the Earth's surface. We use more than 50% of all accessible fresh water. We remove an enormous amount of marine productivity, and our energy use is enormous and growing. Indeed, our ecological footprint, which is a concept coined to estimate the number of hectares that we need to sustain ourselves and to reduce and remove our waste, has been estimated currently to be about 1.5 planets. If we all lived like Australians do, it would be about 4.5 planets. And of course, along with growing human population goes inevitably species extinctions. Those two graphs are not exactly on top of each other, but they're very, very similar. The background rate that we know from the fossil record of species extinctions is about 1 species per million species per year. And Chris mentioned this figure, the background plus humans is about 100 to 1,000 per million per year. And in fact, there was a recent paper in Nature just a few weeks ago that estimated that this is probably an underestimate. And this is the rough percentage of those groups in those pictures up there that are currently considered at risk of extinction. So just for example, 12% of all birds on the planet considered at risk, 35% of all plants, 17% of all sharks. And of course, now we have a new set of culprits. Land clearing is an enormous one. Invasive species, I put that cat up there. There's an estimated 15 million feral cats in Australia. Each of them is estimated to kill about 5 animals per night. That is an incredible 75 million animals every single night being killed by cats in Australia. It's really quite extraordinary. Then we have overexploitation of things, especially like our fisheries, and of course, climate change. Of course, a lot of people say, well, the climate's changed throughout history, CO2 has gone up and down throughout history, and that is absolutely correct. This graph shows the CO2 record going back in time about 400,000 years, and you can see that it's bumped around between about 180 parts per million and 280 parts per million over most of that time. It's now 400 parts per million. I don't think that looks like natural variability at all. This is a shorter time frame. We've put about 30% more CO2 into the atmosphere since the Industrial Revolution, mainly from the burning of coal and oil, than before that time. And this is the impact that it's had. Each of the bars on this graph is the temperature, the difference between the temperature in any one year going back to the Industrial Revolution and the average over that time. The blue bars are all of those years that were below average temperature, and the red bars are all the years that were above average temperature. And you can see that from about the late 70s, every single year is above average. So this is a picture of our potential future. That little wiggly black line is the temperatures that we've had so far. We're about there. The blue area is our future if we manage to reduce greenhouse gases very, very rapidly and very, very seriously. The red area is if we don't. That's the business as usual scenario. The 2 degree line is drawn there because 2 degrees was agreed by about 200 countries around the world as a measure above which we do not want to go. So 2 degrees above pre-industrial levels, we don't want to be above that. Unfortunately, most climate scientists consider that the way we're going, a 4 degree future by the end of this century is very, very likely. So what does that mean for species? Well, this was one of the first estimates of extinction risk from climate change. I was involved in this paper. It was published in Nature in 2004. It was very, very controversial at the time. But I think the important thing about it was that it got the phrases climate change and extinction linked together in the minds of the public. And it estimated that between 2 and 4 degrees above pre-industrial, between 20 and 40% of all species on the planet would be at increased risk of extinction. What about ecosystems? Well, ecosystems are currently suffering a rate of warming of about 0.13 degrees per decade, and at the polar regions, the higher latitudes, it's about 3 or 4 times that figure. And we know that to keep up with climate change, most ecosystems can only withstand about half of that. Closer to home, and that map there is the hottest day in history in Australia, the 8th of January 2013, where the Bureau of Meteorology had to come up with a new colour on the map to denote over 50 degrees. I'm going to show you 2 maps now to get across to you just how different life in Australia for both us and all our species are going to be. When I show you these maps, the whitey yellowy areas of the continent are the areas that by 2030 and 2070 will be kind of the similar as they are now. The green areas are the areas that'll be a bit different, and the purple areas are the areas that'll be really, really different climatically. So that's the map for 2030. This is a CSIRO study, and as you can see, the bottom part of Australia is kind of green or white, not too bad. The northwest is pretty purple. That's very, very different. Here's the map for 2070. It's really, really, really different. That's all I can say. It just shows you, I think, the transformation that our continent is going to go through in the next few decades. Here's another way of looking at it, and this is an illustration from another CSIRO study. That picture is the World Heritage Area Wet Tropics region around Cairns. Another CSIRO study looked at what will happen to the major centres around Australia with 4 degrees of global warming. Well, plus 4 degrees, Cairns gets the climate very similar to currently being experienced in Jabiru in the Northern Territory. Now, Jabiru has savanna woodland. There's nothing wrong with the biodiversity at Jabiru, of course, but it's not going to be the storehouse of richness of species that the Cairns tropical rainforest is. So Cairns plus 4 degrees and drying equals Jabiru. That's just a couple of examples from the terrestrial environment. Let me give you one example from the marine environment, and coral reefs are the rainforests of the sea. They're the most biodiverse, rich areas in the oceans. When corals get too hot, they expel their little symbiotic algae and they bleach and die. One of my coral reef biologist friends has estimated that corals in the Great Barrier Reef need to be moving south at 15 kilometres every year to keep up with the current rate of warming. And then if you add in ocean acidification, which has gone up about 30% because oceans are very good at absorbing all that extra CO2 in the atmosphere, you get a bit of a double whammy there. And this is a little photo montage put together by that same biologist as to what the future of our coral reefs could be. So the first panel is what we've got now at about, well, it was at 350 parts per million when he made this figure, and 1 degree. Put the temperature up to 2 degrees and get to 450. And remember, we're at 400 already. We start to get algae and sponges overtaking the ecosystem. And then above that, at about 500 parts per million and plus 3 degrees, there's biodiversity there, but it's not something you'd go and pay money to snorkel in. And in fact, the coral reef systems have been said to be the first whole ecosystem that could succumb to the Anthropocene. 2 degrees is the really critical threshold for the Great Barrier Reef. So I'm sorry that's all been terribly depressing, but now I'm going to talk in the last couple of minutes about what we need to do, because of course we can do a lot. First thing we need to do is to reduce all those other stresses that are the other causes of biodiversity crises. Invasive species, land clearing, overexploitation, unsustainable changes in fire regimes, overexploitation and overallocation of our river systems. We need to turn back the clock on land clearing. We need to restore a lot of the regions that have been cleared to go back to some semblance of what they were before in terms of habitat. We need to spend a lot more money. This graph shows the relative spend on environment compared to health and education, and I should point out that this figure was put together before the last election. That green line would be even lower than it is currently and into the future. And overall, one of the most important things we need to do is fix this problem. By not doing that, and in fact it's been estimated that to maintain that not to go above that 2 degrees limit, we need to leave 80% of known fossil fuel reserves in the ground and unburnt. Unfortunately, it's been estimated that, well, between 2000 and 2050, to get to a zero carbon economy by 2050, we can only spend or emit 1,000 billion tonnes of carbon dioxide. It sounds like an awful lot. Unfortunately, 14 years in, we've already spent over 40% of that budget. At the current rate of spending, we'll be there by 2028. And of course, underpinning all of this and really underpinning what we're talking about tonight and what the symposium that several of you will be going to tomorrow is about valuing biodiversity as our life support system. We take it for granted, we always have, and we cannot continue to do so. And that's basically because we've got so much to lose. Thank you very much.
Thanks very much, Lesley, for that marvellous talk. Very informative in terms of the extent of the crisis, its causes, and also what we need to do to try and respond to this. Now I'd like to introduce our second speaker, Professor Manfred Lenzen. Manfred is Professor of Sustainability Research in the School of Physics here at the University of Sydney. He has a PhD in nuclear physics and 15 years of experience in renewable energy technologies, life cycle assessment and carbon footprinting. His current research revolves around the application of input-output analysis to global environmental problems, and of direct relevance for tonight's discussion, he's published research in the prestigious international journal Nature on how international trade drives global species threats. He currently leads 2 research initiatives aimed at developing a collaborative research platform to building large-scale, physically extended, global multi-region input-output frameworks, employing advanced computation and a cloud environment. Manfred's talk this evening is entitled International Trade and Biodiversity Decline. Please join me in welcoming Professor Manfred Lenzen.
Thank you very much, Chris. Now, tonight I'll build on what Lesley has described in her talk, and I'll try to answer the question, what drives biodiversity decline? Now, from Lesley's talk, we've heard a bit about the direct causes of biodiversity decline. For example, Lesley mentioned deforestation. There's also industrial pollution and, of course, climate change. Now, in our research team, we were interested in what are the underlying reasons for these pressures to occur, to destroy habitat, and to cause species threats and extinctions. So tonight, I'd like to discuss this causal chain that you see depicted here in this schematic. Let's start from the right-hand side. So we have, let's say we have species threats and extinctions. They are caused by habitat destruction, and habitat destruction is caused directly or indirectly by industrial activity, pollution, and so on. And this industrial activity is caused by production, because these industries, they want to produce something, whether it's agriculture or manufacturing, doesn't matter. Now, but this production happens because there are people who want to consume something, who demand that industry to produce their products, and in that sense, ultimately, to degrade habitat. So there is where the international trade aspect came in. And in focusing on international trade, we were lucky enough to land a paper in Nature, and tonight I will show you some results that are reported in this paper. So, how did we get there? Basically, we got to our results by combining 2 completely different areas of research. Basically, we combined 2 databases. One database is called Global Input-Output Tables. In essence, they tell you something about economic structure and industrial interdependence. I'll come back to that later. The other database is the IUCN Red List on threatened species. So, 2 databases from completely different spheres of research. So, the IUCN database, was readily available. You can just download it from the website. Basically contains information on the species, where it occurs, what its status of threat is, how severe the threats are, and most importantly, what kind of threats are endangering that particular species. Now, as for the second economic database, unfortunately, that was not so easy. We couldn't download this from the web because it didn't exist. We had to build it ourselves, and that took 3 years because this database was very big and very complex. After 3 years, we basically ended up with a giant matrix. So this is a representation, a color representation of this matrix. Basically, you have rows. Top left corner start with Albania, bottom left corner end with Zimbabwe. And the columns, the same, top left Albania, top right Zimbabwe. Every country is represented by its industries, agriculture, mining, manufacturing, services, and so on. So, and then every element, which is every pixel in this map, is a transaction between one industry in one country and another industry in another country. And this whole map, this whole matrix basically tells you how the world economy works. Right? So we can zoom in. For example, if you're interested in all the countries with A, you zoom into the top left corner. There are all the countries with A, and let's say you're interested in Australia. Here is Australia within this big, giant matrix. And even Australia is very, very, very detailed. And you can see already, like, every pixel is a data point. And this whole matrix over a time series of 20 years contains billions and billions and billions of numbers that had to be put together from a dog's breakfast of raw data information. And that's why it's taken us 3 years. And fortunately, we had to avail a lot of very big workstation clusters and a lot of RAM. And now this is published. You can have a look and play around at this web address. The database is called EORA because it was put together at University of Sydney, which we've heard is on EORA land. Now, to the results. This is, in a nutshell, a result that we got from integrating, from marrying these two different fields of research. So this is a flow map of traded products, traded commodities across the world that embody species threats. Now, you can tell just by looking at it that in essence, world trade is so complex that the whole world, in one or the other way, is involved in facilitating species threats through international trade. We've estimated that about 30% of species are threatened through the international trade of goods and services. I'll give you a few examples. Okay, here's Australia. Basically, this is from the website, and you can, I'll give you the web address later, you can play around here. For example, you can hover across Australia, and then the website will tell you that Australia threatens 1,011 species domestically and over 200 species abroad. Now that over 200 species abroad, that means that Australian consumption sets in motion supply chains that end up somewhere else than Australia and then threaten species somewhere else in the world. For every line, the origin is a point of consumption, of somebody demanding or purchasing something, and the end is a point somewhere in another country or a point of production where production degrades habitat and threatens species. Okay? So for every of those lines, you can also hover about the destination point, and it will tell you, for example, PNG, the end of that yellow line right at the back. 72 species are threatened in PNG through Australian consumption only, and the causes of that is urban sprawl, deforestation, hunting, and so on. And on the web, you can also then drill down into what the actual commodities are that are purchased in Australia that ultimately cause species threats in PNG. Now, going back, I don't know whether you can see it, there's also information that tells you that Australia is a net exporter of species threats. This just simply means that there are more species threats caused by Australian exports than by Australian imports. Yeah? That means that other nations demanding our exports cause more species threats than our demand causes species threats abroad. Now, in a country like Germany, where I come from, that's the opposite, because Germany is a net importer of species threats, meaning that German consumption causes more species threats abroad than the other countries cause species threats in Germany. And that was a quite interesting feature. In fact, we looked at all countries in that respect, and we found there's a suite of countries where there are net importers of, meaning that their demand causes more species threats elsewhere than the other way around, and these are exclusively rich countries, the United States, Germany, and so on. You see the top list, yeah? The grey bars. On the other hand, there are countries who are net exporters of biodiversity, meaning that the demand from outside causes more species threats in that country than that country's consumption elsewhere. And those countries are exclusively poor developing nations. So in essence, what you see here is rich countries outsourcing the demand that impacts on species, outsourcing that production overseas, or sourcing that species impacting production from overseas, and then basically from the other perspective, we have nations who are dependent on export earnings and at the mercy of world commodity prices, who are locked in to a destructive relationship of having to degrade the natural environment for the sake of providing exports. Some of these countries, the production that goes to exports and that threatened species is higher than the production that produces goods for the domestic market. So these countries are really locked in into an ecological race to the bottom, as you could say. They just have to, they're almost forced to degrade the environment for the sake of bringing exports earning into the economy. So just a few examples. You all know the palm oil story, and palm oil it's basically in numerous food products, and of course you've probably seen this before. There's this monoculture plantations for example, in Indonesia, leading to the threats of sort of key species like Sumatran tiger or orangutan. That's quite well known, this story. But also if depending on what brand of coffee you'll be served, somewhere the spider monkey will not be amused because its environment is impacted on by coffee plantations. This is prawn aquaculture, and there are certain pollutants involved in producing prawns in this production. I don't know, I'm not an expert on this, but I've heard that this ray is threatened through industrial pollution. And finally, eating chocolate requires, of course, cocoa plantations, and then a lot of species are being threatened because of this particular agriculture, for example, in the Ivory Coast. And I haven't even mentioned the threats due to climate change. Ms. Lesley has already illustrated this very well. So, what can we do? You probably know CITES. This organization plays a crucial role in keeping an eye on the international trade of endangered species or parts thereof. It plays a very important role there, and given the rates of intervention that come about through the existence of CITES, you can estimate the number of individual animals that are virtually being protected through an organization like this. However, if you do a calculation and look at the effect of, let's say, a fraction only of the palm oil trade, international trade, the number of individual animals that are actually being killed because of deforestation for just a fraction of palm oil reserves is far higher than the number of individual animals that you can estimate CITES has saved over its existence. So what this calls for is that, like the ban of endangered animals or parts thereof, we need to ban or regulate the products, the trade of products that ultimately lead to habitat destruction and species threats. This is perhaps the main conclusion that came out of our study. And on a more personal level, what can we do? Just as checking, if you were in the UK, carbon labels, or making ourselves knowledgeable about carbon emissions from different consumer options, we can check whether, for example, seafood is harvested sustainably, and so on. So know your labels and try to shop better. That's on a personal level, something that we can do. So ultimately, coming back to the initial research question, what drives biodiversity decline? So if I had to give a provocative answer that stimulates the question and answer session is about to come, I could say, well, it's us in this room. We drive biodiversity decline by driving this shopping trolley. Thank you.